Hi guys, we're working on some limits at infinity, horizontal asymptotes, however you want to deal with it. And I know these guys dealing with the radicals can be a pain in the butt, so I thought we'd get a couple more of these out of the way. All right, now, if you remember, okay, the powers of x are really determined by the leading guy. Okay, assuming it's written in standard form where the leading guy has the highest exponent, okay, or the highest degree. So really, the numerator, the highest power of x is really determined by x squared. And in the denominator, the higher power of x is really determined by this x to the fourth. Okay, so we kind of think in terms of, this top guy would be like x to the 2/3. Okay, and this bottom guy would pretty much be like x to the 4/6. Okay, so if you look at this guy, we can reduce that guy and we get x to the 2/3. Okay, so notice what's going on here is the highest degree, okay, is x to the 2/3. Okay, so if I take x to the 2/3 and I divide underneath, okay, the cubed root, that would be x squared underneath. Okay, so we're going to get the limit as x approaches negative infinity of the cubed root of, and then when I go underneath, I'm going to be dividing by x squared, so it'd be x squared over x squared, okay, plus 10x over x squared minus 75 over x squared. Okay, then down below we have the sixth root. I'm sorry, and I'm writing cubed root. 7 o'clock in the morning, guys. Okay, so if I want to divide underneath the sixth root, I have to take this 2/3 and express it as 4/6. Okay, so when I divide underneath the sixth root, I'd be dividing by x to the fourth. So that's 2x to the fourth over x to the fourth minus 5x cubed over x to the fourth plus x squared over x to the fourth, and let me extend that guy, minus 7x over x to the fourth plus 3 over x to the fourth. Okay, so we have everything set up there, and now it's just a matter of just simplifying and finishing this up. So let's see what happens here. So I have the limit as x goes to negative infinity. Okay, up above, when I simplify, I'm going to get the cubed root of, notice I'm going to have 1 plus 10 over x minus 75 over x squared. And then I simplify down below, and notice I'm going to have 2 minus 5 over x cubed plus 1 over x squared minus 7 over x cubed, okay, plus 3 over x to the fourth. Okay, so I can actually do my evaluation. Okay, so we know that as x goes to infinity, 10 over x is 0, 75 over x squared is 0, 5 over x cubed is 0, 1 over x squared is 0, 7 over x cubed is 0, and 3 over x to the fourth is 0. So all of these guys that have x's down in the denominators all go to 0 as x gets towards negative infinity. So we end up with the cubed root of 1 over the sixth root of 2, which obviously the cubed root of 1 is just 1. And then I have the sixth root of 2. So I've got to rationalize that. Okay, you got to multiply above and below by the sixth root of something. Okay, so let's see, I have one factor of 2 underneath and I need 6. So I need another 5. Okay, so if I multiply these guys in the denominator, I'd get the 6th root of 2 to the 6th, which is just 2. That's what we're trying to do, rationalize. Okay, so I gotta multiply above and below by the 6th root of 2 to the 5th. So let's see, down below I'm just gonna get 2, and up here I get the 6th root of, well, 2 to the 5th is 32. Okay, and the 6th root of 32 is in simplest radical form. Okay, so there we go, we have our limit. Okay, let's see, this next guy is a little tougher, okay, because we got a whole bunch of roots, okay, and they have different index numbers, okay, so I'm thinking this guy right here, okay, that guy right there is like x to the 2/3, okay, this guy right here, and remember, the terms are in decreasing order of degree, so it's really determined by the first one. So this would be like x to the 3/2. Okay, let's see. This guy would be like x to the 2/4. And this guy right here would be like x to the 3/5. So we look at these exponents and we say, okay, which is the highest degree? Clearly, x to the 3/2 is the highest degree, okay? So we've got to divide everything by x to the 3/2, okay? And this is where it gets tough. Okay, so we say the limit as x goes to -infinity. Okay, let's see. Okay, we've got the cubed root of 3x squared, okay? And we've got to divide by x to the 3/2. Okay, so I've got to figure out how do I make this, index number work out here. Okay, so let's see what we got to do. We have 3/2. We know that's the highest degree, and we want to make it into thirds. Okay, so if I go 3 times 3, okay, 9 equals 2 times an unknown. I don't know what that unknown is. Won't that unknown be 9 divided by 2? So it'd be 9/2. Okay, and look at your proportion. 3 times 3 is 9. 9/2 times 2 is 9. Okay, so that works out. Okay, so if we're going to the cubed root, okay, and I want to divide, okay, underneath by x to the 9/2. So that'd be 3x squared divided by x to the 9/2. Okay, so minus, let's see. This is where I got x to the 3/2. So if I divide by x to the 3/2 underneath, I'd be dividing by x cubed. So this would be 5x cubed divided by x cubed minus 24x divided by x cubed. Okay, so that takes care of the numerator. Now we come down here. I have x to the 2/4, and I need to divide by x to the 3/2. So once again, we look at 3/2. How do I change that into fourths? Okay, not 2/4. How do I change that into fourths? Right here. So notice this one's easy because all I got to do is just multiply by 2. So times 2, that would give me 6/4. Okay, so underneath this guy, I'm going to have to divide by x to the 6th. Okay, so we've got the 4th root, that would be x squared divided by x to the 6th minus 9 divided by x to the 6th. Okay, minus, we've got the 5th root. Okay, and let's see, the degree here would be 3/5. So I've got to look at 3/5. How do I change that to halves? Okay, so let's see what would happen. Okay, I'd get 3 times 2, okay, which is 6, equals 5 times something. So it looks like it's going to be 6/5 is my something, okay? Will that work? I'm pretty sure it will. So if we take the x cubed divided by x to the 6/5, okay, plus x squared divided by x to the 6/5 minus 2x divided by x to the 6/5, okay, minus 4 divided by x to the 6/5. Okay, and I'm going to check this again. Something's bothering me about this one. It might be right. Okay, something's bothering me. Okay, we know the 3 halves. Okay. No, see, that's where I knew something was bothering me. Okay, I think I have it wrong here. So let's go back and check it. Okay, I want to divide by x to the 3 halves. Okay, but it's fifths. Okay, so what's this going to be? Well, 3 times 5 is 15, and 2 times something. So there we go. It's 15 halves is my something. Okay, so all of these guys have to be 15 halves. I knew something there was bothering me. Okay, so these guys are 15 halves. Okay, now we should be in good shape here. Okay, so let's see what happens here. I've got the limit as x goes to negative infinity. Okay. Up above, I've got the cubed root of, let's see, x squared, x to the 9 halves. I know 9 halves is greater than 2, so I know I'm going to get 3 over x to some power. And let's see, if we just go 9 halves minus 2, okay, I'm going to get 5 halves. So that's x to the 5 halves down below. Okay, minus, let's see, we have the square root of, okay, let's see, this would reduce down to just 5, minus, this guy would reduce down to 24 over x squared. Okay, so far so good. Okay, let's see, this guy, we have the 4th root of. Okay, this guy would reduce down to 1 over x to the 4th. I can't do anything here, so that just stays 9 over x to the 6 minus the 5th root of. Okay, I've got to deal with all these guys. Okay, so let's see. Okay, 15 halves minus 3. 15 halves minus 3. Okay, is going to give you 9 halves. Okay, so this would be 1 over x to the 9 halves plus, let's see, right here, okay, I'm pretty sure this will give me 11 halves, right? So give me 1 over x to the 11 halves, okay, minus, let's see, 2 over x, let's see, 15 halves minus 1, so it'd be 50, that'd be 13 halves. Okay, and then there's nothing I can do here, 4 over x to the 15 halves. Okay, so now that everything is simplified, I can actually figure out, well, what happens as x approaches negative infinity? Well, this radicand will go to 0, so I'll get the cubed root of 0 minus, let's see, this part of the radicand will go to 0, so I'd just be left with the square root of 5. Down here, both of these will go to 0, so I get the 4th root of 0 minus the 5th root of, notice that every single one of those is going to go to 0. Okay, so notice I'm going to get the opposite of the square root of 5 all over 0, which is either, that'd be negative infinity. okay? All right, so notice that we get a limit that takes us to negative infinity. So we could say, okay, the limit is at negative infinity or the limit doesn't exist, okay? Either one. Okay, it's just a matter of how you want to state that. Okay, so once again, these guys are kind of a pain in the butt to work with, I'll be honest with you. Especially when you get, you know, all these different index numbers, and so you're dealing with fractions all over the place, and they can be a real pain in the butt. Okay. That'll wrap that video up.